So good morning. Homework tonight is on page 268, 69. I've sort of picked through these problems. They may be a little different than what's on your syllabus. We're still in chapter 4. So I picked through these to make sure that the only types of problems you had would be problems that you were going to be using side, 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 and side angle side to prove. So there are actually 5 ways to prove triangles are congruent. Those 5 ways I've listed up here, so you might want to make a list of all of them in one place. The first I have listed is to show that corresponding sides are congruent. If corresponding sides are congruent, then the triangles are congruent. The second way is to show that side angle side, meaning 2 sides and an included angle, are congruent, and the triangles are congruent. The next way is to show angle side angle, which means you have 2 angles and an included side. If those are congruent, then the triangles are congruent. Next we have angle angle side, where if you show 2 angles and a side that is not included, two angles and a side that's not included, the corresponding triangles, then the triangles are congruent. And lastly, we have hypotenuse leg. Hypotenuse leg is only used when you have a right triangle and you have to have a hypotenuse. But today we're just going to be going over these 2. Everybody got that? So the first one I have up here, and the abbreviation for it is side angle side. Side angle side. So you have a side, an angle, and a side. This angle is between the 2 sides. So if you're looking at a triangle, you'd have 2 sides and an angle which is included or between the 2 sides. Everybody see that? Okay. So this angle is between these 2 sides. So if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So up here I have a picture, not a very good picture, but a picture of 2 triangles. And so my question is, what angle is included in the sides? So on the first triangle, A, B, C, I have 2 sides. I have side BC and I have side AC. And what angle is between those sides? Anybody? Angle C. Thank you. Angle C. Angle C is between those sides. And notice also that the letter C is part of each one of these sides. So you see where it is included. And the other sides are RN and MN. So you see where the angle N is included in the sides. So because of this, we can say triangle ABC is congruent to triangle. Well, I started with A, and I went to B, so I'm going to start with M and go to R and then N. So because side BC is congruent to side RN, and side AC is congruent to side what? MN. And because angle C is congruent to angle N, I can say that these two triangles are congruent because of side, angle, side. Side, angle, side. If you point to it with your pencil, side, angle, side, it's easier to come up with the correct answer when we're going over all of them. Everybody clear about that? So I'll give y'all a minute to write down the information and draw the picture. Let me see if I can get this. So we're given two triangles, triangle ABC and triangle BDE. So the bottom of that's an E, y'all. Okay. So the first thing I'm going to put up here is that AB is congruent to EB, and that's given. And I'm going to mark it on my paper or on the board. AB is congruent to EB. That's an E. And before I put the next given information up there, I want to look at this angle and that angle. That's angle ABC, and it is congruent to angle what? EBD. And what's the reason? Right, they're vertical angles. So vertical angles congruent. So then I'm going back to CB is congruent to DB. And why is that? That's this piece is congruent to this piece. Why is it, y'all? It's given. Now, I didn't put the given up there together because I wanted you to see that I have a side, an angle, and a side. A side, an angle, and a side. So that I know that I'm using side, angle, side. Once again, I think if you point to it you have a side, an angle, and a side. Like I said, I have a side, an angle, and a side. Then I know that these triangles are congruent, so we can say triangle ABC is congruent to triangle EBD. So if you're asked to prove that two triangles are congruent, there are only 5 ways to do it. Okay? Right. I can't get these dots off of here, so hopefully y'all can. So I'm gonna give y'all a minute to copy these down. So you're given that angle A is equal to 40 degrees and angle R is equal to 40 degrees. So this angle is equal to that angle. So angle A is congruent to angle R. Substitution. Then you're given that AB is equal to RS. So this piece is equal to that piece. Mark it on your picture. That's given. So we probably, and then AC is equal to RT. That's given. So how are we going to say that triangle ABC is congruent to triangle RST? Well, once again, if you go back here and look at what you got and point to it, you got a side, an angle, and a side. Everybody good to go on that? Any questions about that? Everybody understand what I mean by side, angle, side, that the angle has to be included or between the two sides? All right. So here's my next example. So let's start with XZ is equal to YZ. That's given. And we have that marked. Then we have ZW, raised ZW bisects angle XZY. That's given. Well, what does that mean if it bisects that angle? Somebody? What does the word bisect mean?
Cuts it in half.
Divides it into two equal parts, cuts it in half. Thank you. So what that means is angle 1 is congruent to angle 2. Definition of angle bisector. So this angle is equal to that angle. Now what do we know about ZW? I haven't gone over this, but I was in hopes that y'all would catch the ZW in both of those triangles. Is it a side to both of those triangles? So my question is this side in both of these triangles, that triangle and this triangle? Yes or no?
Yes.
Yes. It's a side that's in both of the triangles. So we're going to say ZW is congruent to ZW. And what would be the reason? Anybody remember? Come on, somebody must remember the reason. ZW is congruent to ZW. ZW is equal to itself. Say that again.
Reflexive.
Yes, good job. Reflexive. All right. So we could say reflexive property of segments, but reflexive, fine. All right. So now we have that piece congruent to itself. So we can say that those triangles are congruent. So we can say triangle XWZ is congruent to triangle YWZ because of side, angle, side. Everybody good? Okay, so we'll skip this one. Might come back to it if we have time. So now let's look at, and I probably should have reviewed these before we started, but remember the reflexive property says if A is equal to A, and this is true for segments and angles. The symmetric property says if A is equal to B, then B is equal to A. The transitive property says if A is equal to B and B is equal to C, then we can jump over this and say that A is equal to C. And then we have substitution, where if A plus B is equal to C and D is equal to B, then we take B out and substitute D in and get A plus D is equal to C. So those properties of equality apply for segments and angles. So now we want to talk about side, side, side. Where all the corresponding sides are congruent, then we can say the triangles are congruent. So this says if the sides of one triangle are congruent to the sides of another triangle, then the triangles are congruent. So we want to show that corresponding sides are congruent and corresponding angles are congruent. So you'll notice here I have these marked. So I know that AB, side AB, is congruent to side ZT. I have that AC is congruent to ZR, and I have CB is congruent to RT. So because the corresponding sides are congruent, then the triangles are congruent. So I could say that triangle ABC is congruent to triangle. Well, I started with A and I went to B, so I'll have to say ZTR. Everybody good on that one? Those are easy. Okay. All right, what are we trying to prove? We're trying to prove that two triangles are congruent. So far we've only gone two ways to do that. Either side, 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 which is what we're working on now, or side, angle, side. So, ready? Y'all have the picture on your paper? Notice the two triangles are stuck together. Oftentimes when they're stuck together, the reflexive property is going to be part of your answer. Is that clear? Okay, so the first thing we have is we're given CB is congruent to DB. Well, that's easy. It's given. We're also given that AC is congruent to AD. That's given. And if we mark that on our paper, we have this piece is congruent to that piece, and this piece is congruent to that piece. Well, what do we know about this piece right here? What are you going to say, y'all? Well, we know that AB is congruent to itself. And what is the reason again? Reflexive property. So we could then say triangle ACB is congruent to triangle ADB. And what would be the reason? Well, what do we have marked up here? Do we have any angles marked? No. We have three sides marked. So side, side, side. Everybody good? These are by far the easiest proofs there are. Okay. All right. Well, let's look at this one. So it says X is the midpoint of AB and CD. So that's telling you this piece is equal to that piece and this piece is equal to that piece. So CX would be midpoint of CD. AX given X is midpoint of AB. AC is equal to BD, and what's the reason for that, y'all? Come on. It's a given. So we're going to say side, 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 because we have 3 sides and no angles. All right? Everybody good? Any question about that? It's pretty easy, right? All right, I'm going to give y'all a minute to fill this one out. So what'd you say for number 1, y'all? Given S is midpoint of TV. What'd you say for RS is congruent to RS?
Reflexive.
All right. TR is congruent to VR. Given. All right, so we have this is equal to itself, this piece is equal to that piece, and these pieces are equal. So side, side, side. Okay, everybody good? So that takes me down to this picture, which I'm gonna let y'all, that's a circle, and C is the center of the circle. Okay? Even though my picture's not very good. So can y'all handle drawing that picture? Draw the circle first. Okay? Draw the circle first. Okay? Then put a center in the circle. Draw yourself a line, and then from the center, draw the radii to those points. Then draw this line right here. Okay? Everybody got that? All right, so we know that AC is equal to GC because they gave it to us. We know that EC bisects AG, so this piece is equal to that piece. That is also given. What do we know about this piece? We know that piece is equal to itself. Okay. We have that AC is congruent to CG, that's given. We have that EC bisects AG, that's given. That means that AE is congruent to GE, definition of bisector, and it would be a segment bisector. We know that EC is congruent to itself because of the reflexive property. So because we have three sides, and we can say, because of side, 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 and we can say triangle GEC is congruent to triangle AEC. Everybody okay with that? But just because the picture looks complicated, that doesn't mean the proof is necessarily complicated. All right. All right, so going back to the homework, like I said, I carefully picked these out. Page 268, 269, numbers 6, 7, 13, 16 through 19 all, 27 and 28. Okay? And the only, if you're trying to prove two triangles are congruent, the only choices that you know about so far are these two choices. So one of those is going to be your answer to prove two triangles are congruent. Everybody clear about that? Okay. All right. Y'all want to get started on your homework? I'd like to wait and give back the test when everyone's here. We have some people missing. Is that okay with everybody?